Welcome to the lectures on database management systems. In this lecture, we will talk about the introductory part of database management system, and I would like to cover the entire course of database management systems in parts in a series of lectures. To start with, let us have a brief overview of what a database management system is. By the way, these lectures are aimed at undergraduate students, and my intention is to provide lectures for undergraduate students. So let me be clear about that. So because I'm going to start with very basic contents so that they can understand much better. Okay, we'll start with certain definitions as well, and the contents that they see in day-to-day life. In your day-to-day life, you come across so much of data and so much of information as well. So data and information are the words that we use very loosely, interchangingly, but they have their own specific meanings rather. Data refers to a raw fact. It has nothing to do with the inferences that we draw from that. It is only a fact, right? The height of Mr. X, a person X with name X, is 5 feet 4 inches, is a fact, right? The height of Mr. Y is 6 feet 4 inches, is another fact. But if you compare these two, Mr. Y is taller than X. Apart from data, there is some kind of information is also there. Some kind of inference is also drawn from that refers to the information or processing that we have done on the data. So here we talk about data only. We're not talking about information, processed information, but we're talking, to start with, we're talking only with data. In day-to-day life, data is generated at various locations. And knowingly or unknowingly, we are using the database management systems in our daily life. When you open any app, right, they're collecting certain information from you. Where that information is going, how it is being processed. Similarly, if you open any website and if you enter some information in that, where that information is going. So at the back end, there should be something that to hold the data, to process the data, right? So knowingly or unknowingly, we are using database management systems. And the data is being generated at multiple locations in multiple forms as well. If you look at the reservation information system for flights or trains or buses, whatever, so the data is generated continuously at various locations, parallelly, right? If you go to a mall, again, the customer information is generated. Thousands of customers per day, right? Like this, so much of information data is being generated, and where this data is going. We need to store the data. There should be some mechanism to store the data, to process the data. Then what is the use of storing the data? Unless we draw some inferences on the data, unless we draw some conclusion on the data, unless we process the data, what is the use of it? So there should be some kind of mechanism to process the data, and whenever you require an answer based on the data, the system should be able to give you the answer from the data. So three things are there. One, data insertion, and in processing of the data, and data retrieval. Now, since data is generated from multiple sources in multiple formats, we should have a mechanism and we should have a plan to store the data. The way in which we store the data is dictated by a particular model. We need to identify a suitable model to store the data first, and we need to store a mechanism, suitable mechanism also. So the database refers to organized setup that's to store the data. Then, what is a DBMS, database management system? A database management system is a software that deals with the storage of the data. The way in which we take the input also refers to this, storage of the data, processing that we do, and the way in which we interact with the outer world with respect to the data, end users. So a software deals with all the three facets of storage, processing, and output or retrieval. So a software that deals with all the three facets with respect to data can be referred to as a database management system. And the importance of this DBMS is that it is going to engulf all the facets of computer science, because it is going to deal with the operating system that is there, and computer organizational methods that we use, the algorithmic part, algorithms that we write to process the data, algorithmic part is there also there, and mathematical models comes into picture. And once we have the models and once we have the algorithms, right, the end users should also have a look and feel of the data that we show into the outside world, right? So program through programming languages and whatnot, everything comes into in sync with the database management system. So our database management system should be able to tackle all such fields, and it should be able to provide a comprehensive mechanism to store, process, and retrieve the data. Now here we need to understand between a structured database management system and a search engine. Though in the search engine also, if we place any keyword, it is retrieving certain answers. It is also retrieving data and it is giving you the answers. In database management system also, if we give some query, it is going to process it and give the answers. But both are two different things. Both work on different principles. The search engine works on a particular algorithm. It actually works on unstructured data, whatever data that is being hosted on the websites by a lot of people over the internet. It crawls over the internet and identifies the keywords and the information on the web pages. It creates a metadata, that's data about data. It creates indexes and it processes a particular algorithm, specified algorithms on the metadata. Then it computes the importance of the data with respect to the set of keywords, and it presents you as an output. So that is basically over unstructured data, and that is based on purely an algorithmic process. But whereas in DBMS, database management system, we store the data in a structured format. Even the storage of the data itself is in the structured format, and a specific set of instructions are there to process the data, and specific language is also used to process the data, and whatever data is given shall be accurate. Whereas in case of search engines, the data may be relative with respect to the keyword that we type and relative with respect to time. Whereas in database management system, once the data is perfect, the answer should be perfect. So these two are two distinct entities. We need not get confused with these two. So we are talking about DBMS here, which is a structured database. Usually, database management system consists of data about a particular organization or a cluster of organizations. A collection of interrelated data organized in a specific format, and a set of programs to access the data, process the data, and give you as an output, and an overall environment which is conducive for all the parties involved in terms of the end users who are going to use it, the database administrators who are going to manage it, and the application developers who are going to develop several programs on the database. So all the parties should be able to involve in the database management system, and the system should be efficient enough to deal with all the users simultaneously. When it comes to the applications of this in the real world, every entity, every organization now is having its own database. Why? Because a lot of data is being generated on day-to-day basis, and they should have a mechanism to store it, process it, and interact with the customers or the users. So every organization nowadays is having a database management system. Now from now onwards, whatever application that you access through over the internet, try to think in terms of the database that is behind. What could be the database that is there behind the application that you are looking from the front end, right? In that aspect, you try to think, then you'll realize the importance and the complexity of the database system. Now let us have a brief view on the history of the database management system. You can observe that it all started in 1960s with IBM starting a database organization and management processor. It has started with that, and that's a starting step for any DBMS system. And in 1963, Charles Bachman has come up with the data structure diagram, and that is one of the turning points. He was awarded Alan Turing Award, which is equivalent to Nobel Prize in Computer Science, and he has revolutionized the way in which we look at the data. After that, 1964, General Electric has built an IDS, Integrated Data Store, based on the Bachman's idea, and has become a huge success at that point of time. And after that, 1966, Catalysis has come up with another model, and in 1968, IBM has again built another model in terms of information management system, which is based on hierarchical model of database systems. Another variant. But another major turning point in the history is by Edgar Card, who has again revolutionized the way in which we look into the data. He come up with a new mathematical model to organize the data in terms of relationships of relations. That's how he has proposed a model. And again, he was also given Alan Turing Award for his pioneering works. And even now, we are using his model, relational database management systems. Based on his structure, several companies have started creating softwares like Oracle. Oracle and Ingress has come up with their own softwares based on RDBMS model in 1979. Even now, Oracle is one of the front runners or top leaders in these RDBMS softwares. And later, in 1983, IBM has come up with DB2, which is again based on RDBMS. And after that, several variants have come up. But in short, two major milestones. One is by Charles Bachman in 1964, and in 1970 by Edgar Card. So even the present day RDBMS softwares that we are using in our day-to-day life, most of them, many of them rather, are based on relational database management systems, which was started in 1970s by Edgar Card. Still on the history of databases, it all started with 1960s pioneering works on DBMS. It continued up to late 90s. But as I told you earlier, that in 1970s, Edgar Card has come up with a relational model, and that model is ruling the world even now. Even now, it's one of the top runners. But later, several models have also come up, but they are finding their own applications here and there, like multidimensional models and graph-based models. The real change has turned in 2008 or 9, where NoSQL databases has come into picture. Why? Because this relational database management system has provided a very tight framework for the concurrency and the accuracy and consistency of the database and security aspects. No doubt it's working fine. But only thing is, as the size of the data is growing and growing day by day into petabytes, then the query processing is taking a bit longer time when compared with the smaller databases. So then people are finding it difficult to process the queries in shorter time. Still, they are working on algorithms to make it much quicker, but they are facing certain problems. Not only that, with the advent of digital media and the social media contents, the stringent requirements of the RDBMS may not be required for them. So they started thinking in new directions, and they are coming up with their own way of looking at the database models again, and they started with NoSQL databases. So from 2008 and 9, this NoSQL has considerable share, has acquired considerable share in the market of DBMS softwares. Here you can observe that Oracle, SQL, Microsoft SQL Server, and IBM DB2, they are the proprietary softwares for RDBMS, Relational Database Management Systems, and whereas MySQL is an open source free software for managing the data through RDBMS, Relational Database Management Systems. And these are the major softwares that are now running with the RDBMS. Whereas in NoSQL, there are several other softwares are there. When it comes to the NoSQL databases, they have certain requirements like high scalability. Data should be accessible by several lakhs of customers or users simultaneously across the globe through variety of gadgets or through a variety of forms. they want to access. So it should be highly scalable. Not only that, highly available. The data should be available from anywhere and any time. Big data capabilities, even though data grows into petabytes and exponential, even though there is exponential growth, the processing capabilities on big data should be available. And high speed performance is required, fast performance is required. Even though the huge quantities of data is there, we need to quickly answer the queries. That is another requirement. And data replication, if I want to copy a part of the database, I should be able to do it very quickly without loss of any data and without any inconsistencies. So data replication. So these are some of the major requirements of NoSQL databases, and people have come up their own models. For example, Cassandra is being used by Facebook, and Bigtable is being by Google, and MongoDB is one of the general purpose open source software for NoSQL databases. But of course, here in this course, we are talking about only RDBMS, Relational Database Management System. For the sake of understanding, I am giving you the NoSQL databases part. Now let us try to have an overall picture of the current state of DBMS softwares provided by various organizations or companies. Gartner's market share ranking is provided here from 2011 to 2018. I have taken this from tedvisor.com, from the website. So here you can observe that Oracle is a front runner, still ranking number 1, and IBM is at number 2. Slight a bit of loss is there for IBM in the market share, and Microsoft is picking up very recently, and it is picking up its market share. Microsoft is second one. And if you look at the other software providers, you have a very good number of software providers are there. One important major observation here is that in the earlier days, when DBMS was created as a software, either it is in the standalone systems or in the servers of the organization for which it has been created. But with the advent of cloud and the usage of the cloud services, even database management system softwares are also being provided as a software as a service over the cloud. And the new companies or startups that are coming up are more using this cloud-based services for the RDBMS, so that they can reduce the cost of maintenance and ease of use, availability, and all these things can be taken care by the cloud services. That is why, if you observe Amazon Web Services, service providers like Amazon Web Services or Alibaba are picking up, like they have started in mid 2012. If you take Amazon Web Services, and it has grown up to the 3rd position now. Similarly, Alibaba started in mid of 2013. It has ranked about 6th or 7th or 8th position. So it has picked up like anything, right? So this is how the DBMS software is picking up, are being provided by various companies. This is the current state of affairs with respect to the DBMS softwares. So far we have observed the history of the databases and database management systems and the current state of affairs. So what is going to be in future? With the advent of NoSQL databases and the current running RDBMS softwares, now there is a gap between RDBMS softwares based on SQL and NoSQL databases, NoSQL types. Now there is a urgent requirement to bridge the gap between these two. Why? Because the new systems are coming up with NoSQL databases, and the old running systems which are already existing right from 40 years or 30 years are running in SQL. So companies are trying to catch up with the new things without any compromise on the old age-old tested mechanisms. So we need to bridge a gap between these two. So there is an urgent requirement to bridge a gap between these two, which can deal with both simultaneously. And databases from standalone systems or from dedicated servers of the companies, they are now moving towards the cloud. So in the cloud, they are being provided as a software, as a service. And security issues and availability and all these things comes into picture here. And it is also many things there. And automated management. To maintain the databases, can we automate them so that time and effort can be saved? That is also one of the major issues in the current RDBMS softwares. And big data capabilities. Data is being generated in huge amounts, and it is still exponential growth is being seen. So can we imbibe the big data capabilities into the RDBMS softwares? These are all several issues that are now the current state of affairs are facing with respect to the RDBMS softwares. Not only that, so future of databases is cloud based integrated with AI capabilities, maybe the future.